In this lesson, we're going to learn how to simplify expressions with radical and rational exponents. So, in general, a radical is considered to be simplified when there are two things. There can be no perfect factors in the radicand, and we're not allowed to have radicals in the denominator. So hopefully you remember step 2 is where we do that process where it's called rationalizing the denominator. One of the things that's going to be helpful for you will be to recall your perfect squares. So your perfect squares are 1, because 1 squared is 1, 4, because that's the product of 2 squared, 3 squared is 9, 4 squared 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, all the way up to 225, and it keeps going, but that would be 15 squared. That's a good set of ones to know. It's also going to be helpful to know some of your perfect cubes. So this comes from raising something to the third power. So my perfect cube list would be 1 cubed is 1, 2 cubed 8, 3 cubed 27, 4 cubed 64, 5 cubed 125, 6 cubed is 216, 7 cubed 343, 8 cubed would be 512, 9 cubed is 729, 10 cubed is 1,000, and of course they keep going. You do enough of them and you memorize this basic list. You can probably tell I mainly have those ones memorized. We of course have perfect fourth powers. So perfect fourth powers are going to grow even faster. So 1 to the fourth is 1, 2 to the fourth is 16, 3 to the fourth is 81, 4 to the fourth is 256, 5 to the fourth is 625, and when we're going higher than that, if you're dealing with higher numbers, you could just quickly, toss in the calculator 6 to the fourth to see what that is, if it's one that you need, okay? So once they get higher, it's not really all that helpful to, unless you have an excellent memory, to memorize any of these lists. Okay, so what we're going to do is we're going to apply what we already know. And I say you already know how to simplify the square root of 48. So you're thinking, it's a square root, a perfect square from the list that we just generated that would go into 48. And I'm hoping you know that 16 does. It would be 16 times 3. That's 48. So why do we do that? Well, because we know the square root of 16. That's equal to 4. This simplifies to 4 root 3. Okay, so I'm going to apply this concept now to radicals with higher indices, meaning a higher index. So I look at my first new example, 135, or the cube root of 135, and I want to find, this time, a perfect cube that goes into 135 if 1 exists. And just some tips that I could give you is, think about your divisibility rules. 1 plus 3 is 4 plus 5 is 9. 3 goes into this, so maybe 3 to the third is going to go into here. So 3 to the third is 27. So I'm going to check on my calculator, can I divide 135 by 27? And I can. So I see that 27 times 5 is 135. So why did I do that? Because I can take the cube root of 27. This one's rational. I know that. That comes out as 3. So it's 3 times the cube root of 5 stays inside. Now, one of the tips I would tell you to do is type your original in the calculator, get that as a decimal, and type 3 cube root 5 in. And if the decimal matches, that's a good indication that you have simplified this. Now again, check. Under the radical, we have no perfect squares, or in this case, perfect cubes that would go into 5. Other than 1, of course. 1 would go into anything, but that's not helpful in simplifying. All right, fourth root of 80. So with the fourth root, I need something to the fourth power. So, off on the side, I think, okay, so what's 2 to the fourth? 2 to the fourth is 16. So I check, does 80 go into, or does 16 go into 80? And it does. It would be 16 times 5. So I'm going to make this the fourth root. The fourth root of 16 times 5, Why do I do that again? Because I know the fourth root of 16. It is 2. So it's 2 times the fourth root of 5. Again, type the original expression into your calculator and the simplified one to make sure that your decimals match. Let's just make this a little more complicated. So let's again begin with something that we've previously done here. I have square root of 2 times 15 times the square root of 24. So what we previously did in problems like this is we multiplied coefficients together, and as long as they were both square roots, we multiplied the radicands together. So 1 times 15 is 15, and the square root of 2 times 24 was 48. And now I'm going to break down 48. So we just a few seconds ago saw that 16 goes into 48 3 times. So I'm going to take the square root of 16, this part would become 4. So 15 times 4 on the outside, root 3 on the inside, which would give me 60 times the square root of 3. Now again, your calculators, if you type the original expression in just as you see it and this answer, you'll get the same decimal. Of course, you still have to take a look at the radicand right here and make sure that there are no perfect squares other than 1 that would go into 3. So now let's apply this to something new. So let's begin with a cube root example. Now it's important to recognize that the index on each radical has to be the same. These are both cube roots, so I can combine them similarly. Multiply the coefficients together, and then we'll multiply the radicands together. So 4 times 2 would be 8 times the cube root of 12 times 18 is 216. So now we're looking at 216 and trying to find a perfect cube that goes into 216, and hopefully you recognize that as a perfect cube. It is 6. So this would just become 8 times 6, which is 48. Okay, now let's do a fifth root. We didn't generate any lists for fifth roots, but I'll show you a quick strategy. So again, the indices, would be the plural word. They are the same, so -1 times 3 is -3 times the fifth root of 128. So now I'm trying to find a perfect fifth power that goes into 128. So just off on the side, I'm thinking, okay, so what's 2 to the fifth? I know that's 32. I could quickly do 3 to the fifth. And 3 to the fifth is 243, so that's already too big. So I'm guessing possibly 232 goes into this. So if I do 128 divided by 32, I do get 4. So the radicand can be broken up like that. Bring the -3 down, and I can take the fifth root of 32. It is 4, so I'd have -3 times 4 on the outside times the fifth root of 4 on the inside would give me -12 times the fifth root of 4. Again, you can type it into your calculator and make sure that the decimals match.